Hey there. Subscribe to my channel. And also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.
Hi, today in my bench I have this tonylee st8001 power amplifier. From about a year ago I posted the video about how to repair one of these, and today I'm going to do the same in this one. Now, according to the owner, he was using it in a party for a customer, and when they switch the power from the main power grid into the generator power, he smelled something. It is burning from inside of the unit, so immediately he shut it off. So today in this video we are going to tear this unit down, and we will take a look inside and see what went wrong in it and how we can fix it. Now, I already removed all of the screws that hold this cover to the body of the unit, and I'm going to remove this cover and we will take a look inside. So here's the cover has been removed, and I'm doing a visual inspection, and as you can see there is a lot of dust and dirt. Boy, this unit, it is filthy, as you can see in here. Wow. So I can't really imagine how this unit ever run and still running. So yeah, there is a blown fuse in here, as you can see. I think it is blown, I'm not quite sure. And as you can see, here is a blown capacitor, or a swollen capacitor, from the head of it. Now this one fine, and also fine, but this one had it. And yeah, until now there is a suspicious blown fuse and also a swollen capacitor. So yeah, the best way to examine and start testing this unit is to clean it up and then remove this board and test each capacitor individually, and we will go from there. So I cleaned up the unit, and also I disconnected the capacitor board from its place, and yeah, as you can see in here there was a huge fire in the base of these capacitors, or in another term, between these two capacitors. And the fuse, according to the multimeter, it is not hit. So yeah, so I believe we have more than one capacitor has been hit. So yeah, so what I'm going to do, I'm going to remove all of these capacitors and test each one individually, and then we will go from there. So I desoldered and I remove all of the capacitors from their places in the PC board, and once I remove these two capacitors I noticed this really big and awful burn in the PC board. Now, in the previous images of this video we saw that when I removed this board from the unit, that there was a burn trace in the body of these two capacitors and between these two capacitors, but I never think for a moment that the PCB has this type of damage in it. I thought that there was an SMD part or something shorted, but as you can see, the problem, it is much more bigger than that particular assumption. So yeah, I examined the capacitors using the capacitance tester, and these 3 capacitors, they're gone. As for these 2 capacitors, they are the one that they installed in this position, or in this point. And if we take a look at the body of these 2 capacitors, we can really see that the plastic wrapper of the capacitor, it is melted, and also the aluminum housing of the capacitor, it is also melted. Now this one, as you can see, it is not it doesn't have a huge amount of damage, but if we take a look at this, we can see that the aluminum, it is melted. So the short, whatever led to this problem in the PC board, it created a short, and that short melted the produced heat, and that heat melted the 2 plastic wrapper of the capacitor, and also made a short with the body of the capacitors, the 2 capacitors, and made a very powerful short, and led to this catastrophe. If we zoom in a little bit, in order so we can make a close inspection of the burn, we can see that the 2 capacitors are connected in parallel, and the burn mark, it occurred under these 2 capacitors and between these 2 capacitors, and also between these 2 traces. So this point, it is a very sensitive point, and to be honest, this is this is the weirdest type of fire or burn that I ever encounter in a PC board. Wow. Now I measured the resistance between these 2 pins, and I got around, or these 2 traces, and according to the VUM, I got around a 200 ohm, and it is keep changing from a moment to another one. So the PC board, or the fiber in the PC board, it has been turned into a carbon, and it become conductive. And because I want to make sure that this is the only place that it is had the short or had the problem in it, I remove the bridge diode and I tested it, and this bridge diode, it is, according to the testing, or with the VUM, it is still working, and it doesn't have any kind of problem in it. And of course, I also removed this capacitor, and I also tested it, and also I tested this 4.7K 2-watt resistor, and it is also working. These 2 parts are also working fine. So yeah, this burn trace in the PC board, it is turned the fibers into a conductive carbon. So yeah, and if we just probe these 2 traces, as you can see, we still getting a 200, maybe 210, 220 ohm, or around that value. So wow. So what I'm going to do with this, I will try to clean up this entire board and desolder all of these components and try to clean it, and I will scrape and remove much I could from this burnt fiber in the PC board, and we will see if we can remove this short and other so we can bring this PCB back to life. So after a lot of poking, scrubbing and digging around, I was able to remove about 99% of the burnt fiber in this burnt hole. And I cleaned up the hole in the PCB with some cleaning solution, and as you can see, it is very clean now, the hole in the PCB. Now if we measure the resistance between these two traces with the VUM, and I set the VUM to the 10K range, and this is the highest range that this multimeter has, we can see that there is no resistance whatsoever. So the PCB traces are working like it should be. A coat of clear resin will patch this hole up, and it will fix it, and the PCB will be back as new. I desolder these two Zainers, and I tested the resistance and the capacitors and other component in this PC board in order so I can make sure that there is no other fault in this board, and everything it is working like it should be. Now this unit, it uses the Zener resistance configuration as a regulator circuit in order so it can they can regulate the power to the op amp. Now this type of circuit, it is very cheap, and I don't like it because in order this circuit can do a job and regulate a very stable power, the input of the transformer needed to be regulated as well. But this is how they use, and yeah. Now after a close inspection, and if I just zoom in a little bit, we can see that after I clean up the board, we can see that there is a corrosion in here, in here, in here, and so on. And this corrosion, it is compatible with the rims of the capacitors. So yeah, as you can see, it is very compatible. So what happened is, and this led or what happened in this board and what led to this burn that almost made a perfect hole from the side to the other side of the PC board, that the factory, it uses a let's say it is a sponge glue or sponge adhesive that they use it in the furniture business in order so they can glue the capacitor and hold it to the PCB prior soldering. And that glue, it would interact with the soldering mass and corroded and make the corrosion and make the short between the copper traces of the PC board and the body of the capacitor. So yeah, this is a problem in these kind of units, or typically all kind of Chinese units, that they build a really decent thing, but they always left something as a sort of a weakness in order so when it fails in this manner. Lucky for the owner that he sends the the burn smells, and he shut it off when he smell it, or this PCB would gone. So yeah. So what I'm going to do now, I'm going to resolder all of these components and patch up this hole like I said, and reinstall all of these capacitors and replace the faulty ones, and we will assemble the entire thing and see how the unit will work. So I filled the hole with some clear resin, and I waited for the resin to be cured, and once the resin has been cured, I laminated the area that it is under the capacitors in order so I can protect the exposed traces in the board, and also to ensure that there is enough isolation between the capacitors and the traces, for this incident will never happen again. And as you can see, I replace and resolder 3 capacitors instead of the faulty ones, and also I reinstall these 5 capacitors, because after I tested them using the ESR tester and the capacitance tester, these capacitors perform really good, and they have many years still in them. So it is pointless to replace them at this moment. So yeah. Now these capacitors that I installed, these are made in Malaysia, and these capacitors are a lot more higher grade than the old one, because they have what they call in the business as a holder or secured pins. As you can see, here is one of the capacitors that I replaced. They have these 2 pins, so they can be soldered and be secured once they has been soldered to the PCB, in order so they don't wiggle around. The original one, if we take a look at one of the faulty ones, we can see that it only have these 2 pins, while the one that I installed has additional 2 pins. So yeah. Luckily the PC board has it is designed to accept this model of capacitors, so yeah, I installed them immediately. And as you can see, I cleaned up the board really good, and the board, it is really clean now, and it is ready to be installed in the unit. So I'm going to install this board and connect all of the wires, and we will see how the unit will behave. So here is the power supply board, has been installed into the unit, and I re-secure it with its holding screws. And I tested the 2 amplifier assembly using a multimeter, and it is a simple test. It is usually done by measuring the resistance between the minus and plus power rails and the ground. Now in this model of amplifier, or in this power amplifier, there is 2 types of power rail. There is minus and plus high voltage power rail, and there is also a minus and plus low voltage power rails. Now between the power rails, the high voltage power rails, and the ground, there is a certain resistance, and between the low voltage power rails and the ground, there is also a certain resistance. Now I got this resistance in this channel, and it seems that it has the right resistance between these power rails and the ground, but in this channel I did not got it. So yeah, this test tells me that there is a possible problem in this channel, but I cannot say for sure until I plug it in and test it. But for now, I'm going to plug in this power amplifier to the power supply, and we will power on the unit and we will see what will happen. So here is the unit has been plugged in to my voltage limiter circuit, and that circuit will cut off the power just in case this power amp draw a huge or abnormal amount of current, and that will prevent any type of malfunction from to become increased. So let me flip the power switch and hope for the best. So here is the power switch, has been flipped, and as you can see, the protection relay, it is on, so, and the LED, it is off, so that tells me that this journal, it is working like it should be. So wow. So let me get my DMM and test the voltages and see what kind of voltages that the power supply board it is giving. So here is the DMM has been connected, and let's test the high voltage power rails, and it is giving 137 volts. At the low voltage power rails we are getting 68 volts. So this is a positive rail. Now let's test the minus or the negative rail. As we can see, we are getting a minus 68 volts at the low power rails, and we are getting a minus 136 at the low at the high at the negative high power rail, as we can see. So there is a 0.3 volt, it is different between the positive and the negative, and that is completely normal. So yeah, I believe we have a working power supply and also a working amp. So let me connect this channel and we will see what we will get. So here is the other channel has been connected completely to the power supply and to the power transformer, and now I'm going to flip the power switch on and see if this power amp it is going to work or not. So here we go. Wow, as we can see, there is a short that it is happened in this power amp. Definitely a short. So what I'm going to do, I'm going to disconnect all of the wires and remove this power amp, and we will see what kind of problem that it is in it. So I removed the right channel assembly from its place, and I disconnected all of the wires that connect this channel to the rest of the unit in order so I can work and test this channel freely and without any kind of problems. And I started testing all of the resistors, transistors, and the pre-driver transistors, and also the output transistors using the VUM. And because I am used to fix and deal with this model, I can test and perform this kind of test without the need of disassembling the entire thing. So yeah. Now, because the malfunction or the previous fault, it was in the filter capacitor board or in the main power board, and especially in the positive one or in the positive rail, I expected that the problem it is on the positive rail, and therefore the positive rail it is feed the the NPN transistor, the C 5201 200, and the complementary of that number it is the A 1400 or 1943. I tested the C5200 using the VUM, and none of them showed any abnormal measuring. But when I tested the A1943, I found two very high leakage in the two transistors in the pre-driver circuit. So yeah, the output transistors they are okay, but the pre-drivers they had a higher leakage than normal. And to be honest, this is not what I was expecting, because usually when there is a fault in some kind of power rail, that usually the fault it happen near on in that power rail. So if you have a fault in the positive, usually there is a fault in the transistor that they are fed in that a particular rail. But this is unusual malfunction, because these numbers, the A1943, they are fed with a negative rail, and this is really unexpected. Anyway, I removed the two screws from their places that they hold and secure the two transistors to the heatsink, and I'm going to replace them with brand new ones. And I also continue the testing of the rest of the component, and I found the this fuse over here that feed the power of the to the protection circuit, it was blown. So yeah, that is totally to be honest, this is the weirdest kind of repair that I done in this model ever. So yeah, and if we take a look at the fuse, you can see that it is faulty. So yeah, so I'm going to replace these two transistors with a brand new one, and also I will install a brand new fuse. And yes, if you're going to say the fuse it is going to blow again, no, I tested all of the component that it is fed and by this fuse, and they are all working fine. So there shouldn't be any kind of problem. My guess is that when the power supply failed, the negative become stronger than the positive, and that what led to the biasing circuit to become unstable, and these two had it. As for this, I believe the capacitor show a higher resistance when the power become increased and the fuse blow up. I hope this is the end of the problems in this channel, but we will see after I replace all of these components and I plug it in and test it. So let's begin. So here is the power amp has been reinstalled into the unit, and I already plugged in all of the wires of the power rails to their places in the power supply board, and I'm going to power on the unit and see if this channel it is going to work right, or there is other problems still hidden in it. So here you go, let me flip the power switch. And as we can see, the power protection LED has been turned off, so this is a really good indication that this channel it is working like it should be, and the fan it is working like it should be, and there is no abnormal heating in the heatsink. So this tells me that this amp it is working like it should be. Now to confirm that, I'm going to connect my my multimeter to the output of this channel, and we will see if we are getting abnormal voltages or not. So I connected my VOM probes to the output of channel A, and I'm going to turn on the unit and see if there is abnormal voltages are going to be produced in this channel or not. So here we go, and here is the protection relay has been kicked in, and as we can see we have 0 volts in the output of this channel, and that is really good, and this is a really good indication that this channel it is working like it should be. So let me flip the rotating switch to the AC range and select the 10 volt, and as we can see we have a 0 volt also in the AC, and that is really good. So I'm going to simulate that there is a signal has been connected to the input of the channel A, and see if there is motion in the multimeter or in the DMA or in the VOM needle or not. And that is done by connecting a 6mm jack into the input of this channel, and I'm going to touch the signal pin with my hand with the volume all the way open. So here you go, here is the jack has been inserted, and here is the volume, it is wide open, and as we can see we have movement. So the channel A it is working like it should be. So I'm going to disconnect the probes from the channel A and connect them to channel B, and we will repeat the same process. So here is channel B has been connected, and I'm going to turn on the unit now and see if there is abnormal voltages, and indeed we don't have any kind of voltages in the output of this channel. And if we flip the switch or the rotating switch to the 10 volt AC range, we can see that we also have 0 volts in the output of this channel, and that is really good. So now I'm going to boost up the volume to the max and try to touch the signal pin with my finger and see if there is any motion in the multimeter. And as we can see, there is motion when I touch the signal pin, and this is a really good indication that channel B it is working like it should be. So in order I can confirm that these two channels are working right, I'm going to get my oscilloscope and my frequency gen and connect them to this unit and test the output of these two channels and see what we are getting, what kind of signal we are getting. So here is my test gears has been connected to the input and to the output of channel B, and I'm going to monitor the output of this channel using the oscilloscope and the DMM. Now the purpose of this test not to measure how powerful or how much power this amp assembly it is going to produce. My only concern is that this amp it is going to produce a clear signal or not. So let me turn on the unit and see what type of signal that channel B it is going to produce. So let me boost up the volume, and here we go. As we can see, the output of channel B, it is very good, and the output and the sine wave in it, it is very clear. So yeah, so this test tells me that channel B, it is behaving like it should be, and it is working very well. Now I'm going to switch all of the connectors and all of the test gear in order so I can probe the output of channel A and repeat the same process. So I connected my test gear to the input and to the output of channel A, and let's power on the unit and see what kind of output channel A it is going to produce. And here we go. As we can see, channel A, it has the same type of signal like channel B, and the signal in it, it is very clear and very strong, and this is really good. So I believe we have a working amplifier in both channel, the A and B, and all what I have to do now is just hold these wires with the wire holder or the wire gripper like they came from the factory, and close the hood, and this amp, it is ready to be delivered to the owner. So I hope you enjoyed this video. If you did, please like, subscribe. Thank you for watching. See you next time.